right, Catherine. This is lesson 1, and this is lesson 2. We've been done with lesson 1 for a while.
Yeah.
And we did the happy birthday app here, remember?
Oh, yeah.
And in lesson 2, we started to make the Just Java app.
Yeah, the coffee ordering app.
Right. So our learner has traversed this long, arduous journey and is right here.
Yep, at the beginning of lesson 3.
Right.
And this is where we need to keep working on the coffee ordering app.
Okay, so before we talk about that, let's just move all of this aside so we can focus on lesson 3 a little bit better, yeah?
That sounds
So
good.
I'm just gonna drag all of these around
Move
here.
this there. I'll move this here.
Okay, good.
Here's lesson 3.
Okay, how many big ideas are there in lesson 3?
I think we can do 4 big parts.
Okay, let's just split these into 4 piles then.
Okay. That would be good.
There it is. Okay, and what are these ideas?
The first one is methods.
Methods. Okay, well, let's begin here then.
So how did you get to work today?
I have a bike. Works out just fine. How about you?
Okay. I drive.
Oh, cool. How's that car working out?
It's good.
Yeah? Do you know how it works underneath the hood?
No, I don't need to. I just need to put the key in and then I drive it.
You know, this is kind of like writing code.
In what way?
Well, everything is kind of like
Okay,
writing code. But
yeah.
Stick with me for a second, right?
Okay.
In previous lessons, we gave students a bunch of code.
Yeah, we gave them methods like the display method and the display price method.
Right, and we kept saying, well, don't worry about this. We'll talk about what it does later. Right? Well, that later is now.
Okay.
Okay. So much like how you know how a car works, you can use it. Students were able to use that method.
Okay.
Right? But we wrote the method, so we were the designers of the car in that case.
I see. So the main idea is that you can define a method somewhere,
So that's like building the car.
and then later you can call that method.
That's like driving the car.
Yeah,
So let's use those ideas next.
sounds good. Within the main activity.java file, this is where the display method is defined. And this is where it's getting called, within the increment method and within the decrement method. The instructions of the display method take in a number and then display it on the screen, like this right here. Instead of defining a method, we can also just take the instructions inside of it by copying it and then pasting it where we called that method. And since number is not a variable here, we're going to change it to quantity. If we want to do the same for the increment method, we'd copy this code and then paste it up here. So this code works the same as we had before, but now we don't need the display method. The disadvantage to this implementation is that we have duplicate code in both methods. Instead, if we define the display method and then we just call it by its name, then we can have less code, which is better for the app. I also want to show you something else that's cool. Anytime you see a method, you can click on it and then right-click and then go to declaration or Command B if you're on a Mac. This scrolls the file to where the method is defined. This is useful because then you can see the actual instructions that are contained within that method. For other methods, it may open up a declaration in the Android framework code. This was written by the Android team, the TextView Java file. This shows that even though things may look like magic, you can always trace it back to the lines of code where it was defined, either by you or by someone on the Android team. To help you understand the difference between defining versus calling a method, let's modify the main activity. We're going to change the way a method is defined by changing the name of the display method to the name displayQuantity. Then for calling this method, do we need to change anything about that code? If these changes cause an error in your app, make sure to address that so that you can run the app on your phone again. Check these boxes when you're done. Let's do the first task. I'm going to change the name of the display method to displayQuantity. Now this causes some errors in our app. If I scroll up, I see an error that says cannot resolve method display int. This is actually related to the second task, where we asked if you need to change the way that the method is called. The answer is yes, because when we change the name of a method, we need to change the way that it's called. So in the increment method, I'm going to change this to say displayQuantity, and in the decrement method, I'm going to change this to say displayQuantity as well. Now there's no more errors in our app, and I can save this and then run the app on the device. And the app works as expected. There's no user visible change, but internally in our code, we did change the method name. Earlier we saw that we can pass a number into the display method. Let's talk more about the different inputs and output of a method. Let's look at the submit order method in the main activity as an example. Say you have a bunch of lines of code in that method. When the user clicks on the order button, it will trigger the submit order method to be called. The Android device will execute each of these instructions from top to bottom, and when it hits the calculate price method call, it will jump over to where the calculate price method is defined. Say that this is defined at the bottom of the main activity file. The Android device will execute each of these instructions from top to bottom of the method, and then it will jump back to the submit order method. Then it will continue executing these instructions until it hits the end of the method. When the calculate price method is called, we can pass a bunch of inputs over so that when we're executing these lines of code, we can use these input values. As a result of this method, we can pass a single output value back to the caller. That way, the output value can be used in the subsequent lines of code. In Java, we call the inputs to a method input parameters, and we can have 0 or more input parameters. In Java, we call the output a return value, and we can have 0 or 1 return value. An example of an input parameter is passing the quantity over to the calculate price method. That way, this method can use the quantity to figure out the total price of the whole order. And then we can pass that total price back as a return value. And then in the submit order method down here, we can use this total price to do other things like display it on screen or create a receipt or anything like that. So to summarize, this is where we define the calculate price method, and this is where we call it. We want to create a method to calculate the price of a coffee order. Currently, we calculate the price directly in the submit order method, but the logic to calculate the price is going to get a little more complicated, so let's move it into its own method. Then we can call it as many times as we want without copying and pasting the code everywhere. As you gain more experience in Android development, you'll gain better judgment on when to create a new method for something or when you don't need to. This will just come with more experience and more time. So this is the first time we're going to be creating a new method in the main activity on our own. Instead of starting by writing it from scratch, we want to start by learning to recognize what is a correct method by reading some code snippets. So in the instructor notes, we're going to provide you 3 options. Read over these 3 code snippets and determine which option correctly implements the method to calculate the price of the order. When you click on the link in the instructor notes, you'll see this gist. It has code for options A, B, and C. The goal here is for you to become comfortable with reading code that you've never seen before. We haven't gone over the exact rules for what makes a valid method, but I want you to make your best guess on which option you think is most correct. I also encourage you to Google search for more information on how to define Java methods. As you click through the different search results, you'll come across information in the documentation that you don't understand, but I want you to become comfortable with not understanding everything on those pages, because it's perfectly normal to not understand everything. All you need to do is just skim the articles for what you understand and what you think is relevant to the problem at hand. So go ahead and read the code for these 3 options, look up some information online, and then make your best guess on how to correctly define the calculate price method. The correct answer to this quiz is option C. It's okay if you didn't get the answer though, because it was covering topics that we haven't learned about yet. At a high level, I will quickly go through why each option was correct or incorrect, but we'll learn more about all these terms in the following videos. Let's look at our 3 options here and look for differences between them. First, you may have noticed that the lines of code inside each method are the same. Right here, and right here. Also, the comment above each method is also the same, and the comment is just what describes what the method does. And the method is supposed to calculate the price of the order based on the quantity. Another similarity is that they all start with the word private. We don't know what that means yet, but that's okay. The next word here is int. It doesn't say int, though, in option B, but it does say int in option C. So for some reason, it's different here. Let's move on to the next part. Here it says calculate price, and it's 2 words. In option B, calculate price is smushed together as a single word in camel case. In option C, it's also in camel case with no spaces. Then moving along, we see an opening parentheses and then int quantity. There's no closing parentheses though, which is a little weird. In option B, we also see opening and closing parentheses and int quantity. In option C, we see opening, closing parentheses, and int quantity. Then we see there's an opening brace here and a closing brace, but not in option B, and they do show up in option C though. So we notice a bunch of differences among the different options. Let's look at an example of what a valid method should be by doing a Google search. So I'm going to open up a browser and then search for define Java method. You could have searched for a different query and that would have worked as well. This first link looks good. It's from the official Oracle documentation on Java, so I'm going to click on it. If you haven't seen this page before, feel free to pause the video now and click on the link in the instructor notes to skim through this page. While this doesn't match our code exactly, you could try to pattern match the components of this method declaration with our code. This other sentence here is helpful. It talks about how the required elements of a method declaration are the method's return type, name, pair of parentheses, and a body between these braces. Now, I just mentioned a lot of new words, and you can read about them below, but we'll talk about them in more detail later. Let's try to use this information here to help us narrow down our options. If we compare this option with the proper method declaration on the documentation page, this option is actually incorrect. There's an opening parentheses here, but there's no closing parentheses. And in the documentation, it says that we need a complete pair of parentheses, like right here and right here. The documentation also says that a method name has to follow the same rules as the naming for fields or variables. And that means we need to use camel case and not have any spaces in the name. So this name right here is invalid. So it's not option A. Let's go on to option B. Here we're missing the opening and closing braces, which the documentation said were required. Option B is also missing the method's return type, which is supposed to come before the method name. So right here, we should have the word int because we want to return the price as the output of this method. So option B is also incorrect for two reasons, so let's hope that option C is better. Here we have a return data type, which is correct, and then we have a method name that is correctly spelled in camel case. We also have an opening and a closing parentheses, as well as an opening and closing braces. So this one looks really good. Option C has all the required parts of a method. Let's talk more about this next. To figure out why option C was the best in the last quiz, let's review the actual syntax rules in Java for defining a method. This is also known as the method signature. This is the method signature for the calculate price method that we saw earlier. You might be wondering why the order of the words are a certain way. Well, they follow a specific format, and it looks something like this. I know this looks really overwhelming, but don't worry, we're going to go through each one at a time. The first part in this method signature is the word private. This is known as the Java access modifier. It determines who has access to this method calculate price. The most common access modifiers that you'll see are public or private. This method is marked as private. That means that calculate price can only be called within other methods of the main activity. Outside of the main activity, like in other activities, you won't be able to call this method. It's private to the main activity. On the other hand, if you mark this as a public method, then anyone could call this method, whether you're inside the main activity or you're in other activities. It's kind of like this analogy. If you're a celebrity and public, then everyone knows about you. If you're private and you live inside your house all the time, then only a couple of people know you. So for the calculate price method, we're going to keep it private, so it's only used within the main activity. Next we have int, which is the return data type. Do you remember our diagram from earlier where we said that when you call a method, you pass it inputs and you get an output back? Well, the return data type is a type of data that is returned in the output. And the data types we've learned about so far are int and string from the last lesson. This can also return an object data type, and we'll learn more about objects later in the lesson. In our case, this calculate price method is returning the total price of the order, which is an integer. In a social media app, if I had a method to get the number of friends I have on Facebook, it could return an integer, which is the number of friends. Next, we have the method name, which is calculate price in this case. Just like how we can refer to variables with their name, we can refer to methods with their name so that we can execute the instructions in this method. In the same documentation about defining methods, we can scroll to the bottom and see a section about naming methods. You can read about this in more detail later, but basically it says that method names should begin with a verb, like run or get or compare, or set. It starts with a lowercase letter, and then you use camel case if there's multiple words. After the method name, we have the list of inputs, which are denoted within the opening and closing parentheses. You can have as many inputs as you want. If you don't want any inputs, you just have an empty set of parentheses. If you have one input, it looks like this. If you have multiple inputs, you just separate them with commas in between each input. Let's look at the case where we have one input, which is also known as an input parameter. We define an input parameter by specifying its data type and a variable name that we choose for it. So from the diagram of inputs and output, this is going to be the first input to the method. Within this method, then you can refer to the quantity variable, and it's just like any other variable where it already has a value inside of it. The value comes from when you initially called the method and you passed that input in. If we want to modify the method signature to add a second input param, we just have to specify the data type and the variable name for that second input param. Then within this method, we can refer to the quantity or price of 1 cup variables just like the regular variables. When you call this method, you have to remember to pass the right number of inputs to the method that it's expecting, and the inputs must be of the right data type and in the right order. You can't flip the order of these, otherwise the method is going to interpret them incorrectly. After you list out your inputs, add a closing parentheses and then an opening brace. This starts the list of all the instructions within your method. After all of that, then just add a closing brace to mark the end of your method. Going back to our documentation, now this method declaration will make a lot more sense. First we have the access modifier, then we have a return data type, the method name, followed by the list of all the inputs. In this case, there are 4 different input parameters, and they each have a data type and a variable name. And then we have an opening brace, the list of all the instructions inside of it, and then a closing brace. And this is a method declaration. In this quiz, you'll have a chance to practice identifying the different parts of a method declaration. We're going to provide some code to you in the instructor notes. The code contains a bunch of methods that could appear in any app. For each case, can you tell me what is the method name, the list of input parameters, and the return data type? Let's do the sample together. Here's an example method. The goal is to create a custom greeting message based on the given name. The return value is going to be a greeting in the form of some text. Now let's ignore the comment for now. First we have the method name, which is in camel case here, and it says create custom greeting. Next we have the list of inputs. This is the first input parameter. The data type is string and the variable name is first name. Next we have the second input parameter. This is the data type and this is the variable name. And the 2 inputs are separated by a single comma, and they're enclosed within the opening and closing parentheses. Then we have the output here. The data type of the return value is string because we want to return a greeting, which is a string. And this is what it looks like filled into the table. Now go ahead and fill in the blanks for the remaining 3 methods. Let's walk through each of these methods and then fill in the table. This is the gist of code that we provided to you in the instructor notes. Let's start with method 1. This method is meant to create a reminder message for a particular calendar event. The message will be composed of the event name and the event location, as well as how many minutes away the event is. So the method name is create calendar event reminder in camel case, and then the list of inputs is in between the opening and closing parentheses here. There are 3 input parameters. The first is string event name, then string location, and then int minutes away. The output of this method, or the return value, is the reminder message, which is text. So that's why the return data type is a string. And this is what it looks like filled in the table. Technically, this should all be one word without any spaces, but it just doesn't fit in this box. And this is the second method. The goal of this method is to deduct a certain number of points that were used from the overall number of points, which is 100. So it returns the remaining number of points. The method name is called deduct points, and there's 1 input parameter in between this opening and closing parentheses. It's called points used, and the data type is int. The return value is the number of points remaining, and that's a number, so that's why the return data type is an int. In the table, this is what it would look like. And this is the third method. The goal of this method is to create a text string that says the sum of all the individual trip lengths. The method name is findTotalTripLength. Then we have to scroll to the right to see all the parameters. We have 3 input parameters here in between the opening and closing parentheses, and they're separated by commas. The first is int distance of first trip, second is int distance of second trip, and int distance of third trip. So within this method, we can refer to each of these variables. Since they're integers, we can add them all up to the total length of the trip, which starts at 2 miles, and then we can concatenate that to this string message. Since this message is text, the return value of the method is string. And this is what it looks like in the table.
Wait,
What's wrong?
when did this turn into a cooking show all of a sudden?
Since we had to talk about methods?
Care to explain, Rachel Ray?
Well, have you ever baked a cake before?
I have eaten a cake before.
Okay, well then you're fully qualified for this.
Okay.
All you have to do to bake a cake is to put in like flour, sugar, and
The
different
ingredients. Okay.
Yeah. And then you follow the instructions of the recipe.
Okay.
And then out comes a cake.
Like this?
Yeah.
Okay. Well, connect the analogy to the methods one more time.
Okay, sure. So for a method, you can put in inputs.
Like we did the quantity for the display method.
Yeah. And then you execute the instructions of the method.
Okay. Almost like the recipe for making a cake.
And then you can have the output value returned.
Outputs, they're delicious.
Let's look up more information about input parameters for methods. I'm going to do a Google search for Java method parameter. The first link looks good, so I'm going to click on it. Now this article talks about passing information to a method. Here's a code snippet that computes the monthly payments for a home loan. It has 4 input parameters: loan amount, interest rate, future value of the loan, as well as the number of periods or the length of the loan. And then inside this method, we see that we can use these input parameters simply as variables to do our math calculations. When we call the compute payment method, we have to make sure we pass in the inputs in this specific order. So the loan amount has to go first, and then the rate, and so on. For the quiz in this section, you'll have a chance to review this article in more detail. Within the main activity of the Just Java app, we're going to be modifying the display quantity method and the input parameter to give you some practice. Notice that in the decrement method of our app, when we call the display quantity method, we're passing the quantity variable over as input to this method. But the input parameter is called number, so whenever we want to refer to this input, we just have to say number. Now technically, we could have used the global quantity variable within this method instead of passing it as an input parameter. But for the purposes of teaching you about input parameters, let's just leave it like this. I can change this call to the display quantity method so that I pass as input the number 30. This is valid because it still matches the input data type. So in the decrement method, when we call display quantity, it will jump down here and it will execute these instructions, and the variable number will have the value of 30. I'll run it on my device to show you. So now when I hit the minus button in the app, it will display a quantity of 30 here. So let me try that. There, and it actually happened like that. I can also create a different variable and pass that as an input to the method. Here I created a local variable called SumQuantity, and I initialized it to 100. I pass this variable as input to this method, and now the number variable inside here has a value of 100. Let me run this on the device. Now I expect that when I hit the minus button, the quantity will update to 100. And it does. These are just some things you can do to experiment with passing in different inputs to a method. As you work with input parameters, another term that you might come across is arguments. When you call a method, the inputs being passed to that method are called the arguments. Now, this is kind of a funny word because when you think of arguments, you think of people yelling and cursing at each other, but this is not like that. Arguments are simply the inputs being passed to a method. Input parameters are the actual inputs in your method declaration, and those are the variables that are used within your method. So that's a slight difference between input parameter and arguments. In any case, go ahead and read the article in the instructor notes about method parameters. Then go ahead and experiment with the code in your app. First, try to rename the number input parameter within the displayQuantity method declaration. Just simply give it a different variable name. Then go ahead and fix any errors and then run the app again. For the next task, go ahead and change the data type of the number input parameter from an int to something else like string. Observe what happens. Then go ahead and undo the change. If you want to experiment with other things, go right ahead. For example, if you have a question, what would happen if I do X? Then just go ahead and try it. Let's do the first task. We're going to rename the number input parameter to have a different name. This is the first input parameter, int number, and all I need to do is just change the variable name. I'm going to change this to, for example, number of coffees. It can be any name that you want. Now, I immediately see a warning and an error. The warning says the parameter number of coffees is never used because nowhere in this method do I use this variable. Then I see that there's an error that says cannot resolve symbol number. Now there's no variable called number. There's no local variable called number, there's no global variable called number, and it's not an input parameter either. Instead, I need to switch this so that it's called number of coffees. And there you go, that fixed the error. So I'm going to run it on my device now. And this is what it looks like. The quantity picker works as expected. There should be no visible change to the user because we just modified the name of an input parameter. Also, we didn't have to change the way that the method is being called. We can still say display quantity and then pass in anything we want. It doesn't matter to the caller what this input parameter name is. The second task is to change the data type of the input parameter from int to string. So in the displayQuantity method, I'm going to change the input so that instead of an integer data type, it expects a string data type, like this. And now there's a couple errors in our app. When I scroll up, I see that there's a red squiggly underline in the increment method and in the decrement method. The error message says, display quantity string in main activity can't be applied to something int. What it's saying is that we can't pass the quantity variable into the method anymore because this is an integer and it's expecting a string. This mismatch in data type is causing an error and the app won't even run on our device. This is a compile time error. There's a couple ways to fix this. Either we have to change what's being passed into the method so that this is actually a string. I could put 100 here and put it in double quotes so that it's a string, and that would match the right input type here. But what we really want is for quantity to still be an integer so that we can do math on it to increase it by 1 or decrease it by 1. So I'm going to leave this as quantity. And then this should be changed to be an integer. And then our app should work again. Cool. So far we've seen an example of a method with one input parameter. But what about examples of methods with 0 input parameters, or 2 input parameters, or more? I'm going to walk you through an example of a method with a different number of input parameters. I started by creating a new app from the project wizard in Android Studio. So this is completely unrelated to the Just Java app. I added this method in the main activity. It's called createWeatherMessage. There's no input parameters, and the return value is a string. This method is supposed to create a new message that specifies the city name and the temperature. You can think of a method as being a template of instructions. So I can make temperature be an input parameter. And it's a number, so I'm going to say int temperature. And then I can use this right here. So this is a string literal, and then it's concatenated with the temperature integer, and then it's concatenated with another string that says degrees Fahrenheit. So now the message can be customized based on the temperature because it's an input parameter. Oh yeah, I forgot to mention this earlier, but in the onCreate method of the main activity, which is called when the activity gets created, I can call the createWeatherMessage. Before I passed in no arguments, but now we have one required parameter. So I'm going to pass in 77 for the temperature. Now that makes the error go away, and this method call is correct. The other thing I should modify is this comment on the method. I'm going to add a blank line, and then I'll start to describe the input parameter, which is temperature here. I'm going to type @param temperature, and then I can add a description saying that this is the temperature of the city. Sometimes the parameter names are a little hard to understand, so that's why the description is useful. Other times, if your method is public, then other people will be able to call this method, and they might not know what are the instructions inside this method, so reading this Java doc and the description of the parameters is really useful to them. I mentioned earlier that a method is like a template, so what if we want to change the city so that it's not always San Francisco? I can make city be an input parameter, so I can just add a comma here, and since city name is text, I'm going to make it a string data type. Then I can delete San Francisco and replace it with the variable city name. I remember to add a space before and after here as well. Cool, so now this method can create a message that's customizable to a certain city and temperature. I also remember to modify the Java doc so that it has this extra parameter and description for a city name. Since I changed the method signature, now I have an error up here. The method no longer works with just one argument. I need to pass in 2 arguments. So I add a comma and then pass in San Francisco string. Now the error goes away. So when I call create weather message, 77 is going to be the value of temperature and San Francisco will be the value of city name. And it will create the proper string here. Now we're going to go back to the calculate price method, and we're going to modify the method signature so that it has a different number of input parameters. We're going to define it with 0 input parameters, 1 input parameter, and lastly try it with 2 input parameters. You'll see how changing the method signature here to have a different number of input parameters will affect the way the method is called. Normally, when you're building your app, you will just define it one way with a certain number of input parameters. And usually that number of input parameters is going to be determined based off of what's happening inside the method. The best practice is to only pass input parameters that you're actually going to need inside this method. There's no point in passing over more information if you're not going to use it inside here. Here are the instructions for this task. First, define the calculate price method in your app in the main activity. See the instructor notes for a code snippet that you can start with. We're going to modify the calculate price method so that it only has 1 input parameter. Then in the submit order method, call calculate price and pass in quantity as the input. Then try to modify the calculate price method to have 2 input parameters. That way, in the submit order method, you'll call calculate price quantity, and then you can pass in the price, which could be $10, for example. And lastly, try changing calculate price so that it has 0 input parameters. That way, in the submit order method, you would just call calculate price like this. Let's do the first one together so you understand what I mean. I'm going to open up the link in the instructor notes. In this gist, we've provided code for the calculate price method. So go ahead and select everything and then copy it. In Android Studio, I'm going to paste in this method. I'm just going to paste it in right below submit order. And I'll make sure that there's a blank line in between each method here. That makes it easier to read. Then I can call this method from the submit order method. I'm just going to insert the call at the very bottom of the method. Later we're going to integrate it with the code up here. But for now, this is good. Oops, I forgot that we have 1 input parameter, so I need to pass quantity. Now do the same for the remaining 2 tasks by modifying the input parameters here. To complete this task, if you need examples to reference, you can always do a Google search for Java methods. We already did 1 input parameter together. This was the code for the calculate price method that was already included in the instructor notes. Now let's do the case of 2 input parameters. In the submit order method, we want to call calculate price quantity, 10, where 10 represents $10 per cup of coffee. So let's first make this change. In the submit order method, I'm going to call calculate price quantity and then comma 10. I'm passing in 2 arguments to this method. There's an error because it doesn't match the method signature here, and I'm about to update that. Inside the parentheses, I'm going to add a comma and then type in int price because we're passing in price as the second input, and that's an integer. Immediately, it says that there's an error because it doesn't match the method signature here, which only has 1 input parameter. I'm going to change it so that it has a second input parameter. So inside this opening and closing parentheses, I'm going to add a second parameter. Since this is the price per cup of coffee, I'm going to call it price per cup, and it's a number, so I'm going to say that the data type is int. The name of the parameter type can be anything you want. It should be descriptive to the information that it's holding, whereas the data type needs to be a specific Java data type, so int, string, and other ones that we haven't learned yet. I also updated the Java doc to describe the second input parameter. When I look inside this method, we're taking quantity and multiplying it by 5 for $5 per cup of coffee. But now the price per cup has changed to a variable. So let's use price per cup instead of hard-coding the value 5. Now the total price of the order is going to be quantity times price per cup. If you think back to the template analogy that I was talking about earlier, now quantity and price per cup are swappable for different values because they're input parameters. You could call calculate price with a different quantity and a different price per cup, and this computation would still work. Now let's do the case of 0 input parameters. In the submit order method, we should call calculate price with empty parentheses. In the submit order method, when I call calculate price, I'm going to remove the arguments. Now we don't pass any inputs into this method. There's a red underline immediately because there's a mismatch with the method signature. So I'm going to go ahead and erase all these input parameters. This is also complaining about an error because these parameters don't exist, so I can go ahead and delete this. Now we get an error saying that it can't resolve the symbol price per cup. It's no longer an input variable, so we need to switch back to the hard-coded price value, which is $5, or you could pick any other price. The computer doesn't complain about quantity because it's actually a global variable, and you can reference this quantity variable from any method in the main activity. Sorry, I should have picked a name other than quantity for the input parameter, but you get the idea. Without any input parameters, you can only refer to global variables, you can use hard-coded values, or if you create local variables here, you can refer to those. We just finished calling a method and passing in inputs.
Oh wait, are you referring to passing in quantity to what was it, the calculate price method?
Exactly. And now we want to get a return value out of it.
I love return values. What is going to be, I think, the price, because it's the calculate price method?
Yeah, the total order price is going to be the return value.
Okay, let's do that.
Okay. Do you need a fork?
Do what?
In Java, the output of a method is known as a return value. In code samples, you may have seen the word return inside the method or seen the word return in the comment above it. Let's look up more information about the return values for methods. I'm going to do a Google search for Java method return value. The first link looks good. This article talks about returning a value from a method. It says that a method is finished being executed when we've completed all statements in the method, or all lines in the method, or when we've reached the first return statement, whichever one comes first. A method will also end if we've thrown an exception or an error, but we're not going to cover that in this course. We're mostly going to focus on the first two cases. So in the code, you might see something like return semicolon. That means the method should end and any lines of code that come after this won't be executed. Alternatively, you might see something like this, return and then a value, semicolon. This is returning an output value from the method. Here's an example. This is code for the getArea method. It's supposed to compute the area of a rectangle, which is defined as width times height. So inside the method, we have the word return followed by the return value. The return value is the variable width times the variable height, and this equals a single number, and that number is returned as the output value for this method. Unlike input parameters, where you can have as many input parameters listed in between the opening and closing parentheses, you can only have a single return value, and the data type of that return value is specified here. So we could have returned any other number as long as it's an integer. For example, you can't return a string because that doesn't match the int data type. You're probably realizing by now that Java has a special meaning for the word return. You can't use it for the name of variables or methods. These are called Java keywords. I can search for the Java keywords list. This is the list of all the Java keywords. You'll notice that some of the words we've already seen before, like int, public, and private. It's a pretty short list, and all these words have a special meaning in Java when you put them in your code. So that means you can't use them for identifiers, like variable names or method names in your app. And you'll also notice that return is a special Java keyword. This is reserved for when you want to return an output value from a method. Going back to our earlier example of creating a weather message, we can create a string and then return it by saying return message. The data type of this variable is string. What would happen if I added a line of code after this return statement? Well, then I would get an error that says unreachable statement, because the computer won't get to these lines of code after the return statement because it would have ended the method at this point. So delete any lines of code that come after your return statement. What if you don't need your method to return any output value? Well, let's look at a couple of examples in the main activity of the Just Java app. The increment and decrement methods are examples where there is no return value. When you call the decrement method, it does all of its hard work in updating the UI in the displayQuantity method. There's no output value to return. And same with the increment method. All the hard work is done when you call displayQuantity and it updates the screen. You might be wondering where the return statement is then. Well, the method will finish executing when all of the lines of code have been completed, or when it hits the return statement. So I could have added return semicolon like this. That way the method would finish as soon as it hits this line. This gives me a warning in Android Studio. It says return is unnecessary as the last statement in a void method. Since I'm not returning anything, I can just delete this line here. This is less lines of code and it's easier to read, so I prefer it like this. To indicate that there is no return value, it's important in the method signature to say that the return data type is void. Void just means that there's no return value. Java has a special way of representing this, so that's why this is a Java keyword. Let's look back at our Java keywords list, and indeed we see that void is in this list. So if you don't have a return value, make sure you don't just leave it blank like this, because otherwise there's a Java syntax error. Just type void with a lowercase v. Go ahead and read this article on your own now. You can skim it for the information that you do understand, or Google search for more information online. Once you've learned a couple of things from this article, you can move on to the tasks. In the instructor notes, you'll find a link to some code for 4 different methods. Each method contains an error, and the task is for you to find the error in each of these methods. Since there's multiple ways to fix the code, assume that the java.comment at the top of each method is correct, and we want to make the code match that. This is what the methods look like. Identify the line number that the error is on. The line number is located in the left-hand column here. Then write a short description on why that line has an error. So line number goes here and description goes here. When you're done, you can continue to the solution video. The first method is about getting the email account name. The method should return a string, which is the name of the account. So far, the method signature looks good. We have the access modifier, the return data type, and the method name, and no input params. We have an opening and closing brace as well. The first line of code looks correct. It returns a string in quotes, and then it has a semicolon. So this is the return value. However, the problem comes on the second line when we see another return statement with another return value. We learned earlier that you can't have lines of code after the return statement because those will be considered unreachable by the computer. So in this case, this method has an error on line 8. Okay, so let's do method 2 now. The second method is about adding $4 of tip onto the current bill. The current bill is an input parameter and the data type is integer. The return value of the method should be the total price of the bill with that $4 of tip included. So let's check the method signature first. We have an access modifier. We're missing a return data type, so that's weird. And then we have the method name and one input parameter. So the return data type is a red flag, but let's keep reading. Inside the method it says return bill plus 4 and semicolon. So this is the return value. Bill is a variable and we add 4 to it, so this evaluates to a single value, and then that is an integer which should get returned. So we're missing the word int right here, and this is on line 6. So in the table we say that method 2 has an error on line 6, and we're supposed to specify the return data type of int. Let's look at the third method. This method is about setting up the app for our current city. We don't have the code for the other app, but let's just look at the code for this one method. The method signature starts with private access modifier, and then it says nothing, which is weird because we haven't seen that before, and then the method name is called setup. There's no input parameters, and we have an opening and closing brace. Inside the method, we see that there's a variable, it looks like a global variable, city name, and it's being set to the string London. Okay, well, from everything that I've observed, there's basically no return data type specified in the comment here. It looks like we're trying to return nothing as the output. So remember that the Java keyword for returning nothing is the word void. So I think the error is on line 4 here when we need to say void. Okay, so I added that to the table. Now let's move on to method 4. This method is about getting the number of students in a class. The return value is the number of students, which is an integer. The method starts with an access modifier of private, and then the return data type is an int. So far it's looking good. The method name is getStudentClassSize, and there's no input params. Inside the method, we have the return keyword, and then it says 20 in quotations. But this is weird because this is a string, and we wanted to return an integer. So the error is on line 7, where we have to return 20 without quotations. And this is what your table should look like. Let's go back to the calculate price method. Once we call this method, it's going to return the total order price, and we can store this value inside this variable called price. Then we can display it on the screen. To integrate the calculate price method into our app, we're going to need to use return values. Let's look at the pseudocode first. Within the submit order method, we want to call the calculate price method. It's going to compute the total price of the order, and it's going to return that as an output. So we're going to store that output into an integer variable called price. Then we're going to take that price and then display it on the screen. Let's look at the actual Java code for that. In the submit order method, we would add this line of code. Do you remember the assignment operator from lesson 2? Whenever I see this, I evaluate the right-hand side first. The calculate price method returns a single value, which is the order price, and that should get stored inside this local variable called price. Then we can call another method, displayPrice, and the input to that method is going to be the price variable that we just created. This is the first time we're seeing how a method can be used as part of an expression. For example, we can call this method, and the value that gets returned from that can be added to other numbers, or if it was a string, we can concatenate it to other strings. All that matters is that the whole thing on the right-hand side gets evaluated to a single value and then gets stored on the left-hand side variable. But for the Just Java app, we're just going to use calculate price directly and show that on screen. For this coding task, you'll be making sure that the calculate price method is getting defined and called properly in the Just Java app. First, focus on how the method is defined. Modify the calculate price method to have the correct return data type in the method signature. Also assume that there's 0 input parameters. The next step is to modify the inside of that method. Make sure that it's returning the correct price of the total order, which is the quantity of cups ordered times the price per cup. You can assume that each cup of coffee costs $5, and you can just hard code that directly into this method. Once that's all done, then you can move on to how the method is getting called. Call calculate price from the submit order method, and you can use the code that we talked about earlier. Then go ahead and display this price on the screen. Now you could use the display price method, but you did a lot of work at the end of lesson 2 to show some text on the screen as well. It also said thank you, so if you could try to integrate this price value with that text, that would be most ideal. It should look something like this, so if you change the quantity and then hit order, then the price shows up here, along with the text. When you're done, check these boxes to continue. First, we're going to modify the calculate price method signature to have the correct return data type. We're also going to assume that there's 0 input parameters. This is where the calculate price method is defined. The purpose of this method is to calculate the total price of the order and then return that. The price should be an integer, so we should change the return data type from void to int. That takes care of the first task. The quiz also said to make sure that there's no input parameters, and that's what we have here. Now the second task is to modify the inside of the method to make sure that we're computing the correct price of the order, and assuming $5 per cup of coffee. Inside this method, we're taking the quantity of cups ordered and we're multiplying it by $5 per cup of coffee. This equals the total order price, so this line of code is correct. But there's two issues that I see. The variable price is never used, and there's an error that says missing return statement. It's expecting us to return an integer, but we're not returning anything. Right now, our code is the same as if we just said this. We need a line that says return and then actually put a value here. And the value we want to return is the price. So I'm just going to put price, which is the variable we defined up here. Cool, so now all the errors go away. We should also modify the Java doc so that we specify that we're returning the total price. That way when someone's calling this method, they know what to expect. Okay, so now we've finished all the parts for defining this method. Now let's move on to where the method is getting called. Within the submit order method, we should call the calculate price method. Currently, calculate price is floating in the middle of nowhere. I'm going to copy it and I'm going to paste it up here because before we would calculate the price of the order in line in the submit order method, but now we have a method for it, so I'm going to paste this here. I'll get rid of the extra semicolon. You'll notice that price is a local variable in this method and also in this method. It's okay if they have the same name because these are different variable scopes. So the price variable here is totally unrelated with the variable here. They're updated and created independently from each other. And once this method finishes executing, this price variable is gone. Okay, back to our submit order method. So we calculate the price and stored it in a variable, and then we can use it to create the price message. So actually all of this code can stay the same. We're concatenating the integer price to the string total with the currency symbol. Then we concatenate thank you and then just display it on the screen. So I'm going to erase these extra blank lines and save it, and then we can run it on our device. Okay, so if I change the quantity and hit order, then it correctly shows $25 as the price. Awesome, it worked. But how can I be sure that calculate price is actually working? Because there's no user visible change compared to our app from before. Here are a couple of techniques that you can do to verify that your code is actually running. I could have it return a really crazy number, like 700. Save my code and then run it. Now what I expect to see is if I change the quantity and hit the order button, it should say that the price is $700. That way I'll know that this calculate price method is actually getting called. And it does. Cool. Now I can revert this change. Another way to check that this method is getting executed is to add a breakpoint here. So I'm going to click on this little bug icon, and then our app will enter debug mode. If I change the quantity and I hit order, then I expect that the app will pause at this point. And it does. So now we're in the calculate price method. There is a global variable, quantity, and if I step over to the next line, then I see that there's now a local variable, price, and it's set to be $15 because quantity is 3 times 5 is 15. Cool, so it's going through the calculate price method, and if I hit resume, then it updates properly on the screen. Guess what time it is?
Time for more cake?
No, it's time for the students to define and call their own method.
Wait, we're asking them to define and call a brand new method?
Yeah.
What's it called?
It's called create order summary. It's going to take a summary of everything they entered into the app and then output that as text.
Do you think they're ready?
I think so. I think it's time for our little birds to spread their wings and fly. Now we're going to change the app so it looks like this. If I change the quantity and then hit the order button, then it prints out a longer summary of the order. This is what will happen in the main activity at a high level. When we click on the order button in the app, we'll call this method, and then inside of this, we're going to call the calculate price method. We're going to call the method with no input parameters. We're going to execute these instructions here, and then we're going to return the price. Once we have the price in the submit order method, we're going to be able to call the create order summary with that price. So we pass in the price to this method, and then we execute the instructions inside of it. And then we're going to return the summary text. And then in these lines of code, we can display that summary onto the screen. To implement that in code, we're going to create the order summary method. This is a screenshot of what the final app should look like. It's the same as what I showed you earlier. The first task is to create this as a new method in the main activity. The method will be called createOrderSummary. It's going to take as input the price of the order, which is going to be a number. Then it's going to return this message. Feel free to use your own name or any other name, and make sure that quantity and total are accurate based on what the user selected in the quantity picker. Then just add thank you. The second step is to then call this new method from the submitOrder method. Once you get this string back in the submitOrder method, then go ahead and display it on the screen, like this. Check these boxes when you're done. Let's do the first step together of adding a new method to the main activity. You can pick anywhere in the file to add your method as long as it's outside of the braces of a different method. I'm just going to add it right below the other method we defined, which was calculatePrice. I'm going to say private for the access modifier because the only things that need to access this method are within the main activity. Then I'm going to say string for the return type because the createOrderSummary method should return a string, and then the name of the method is createOrderSummary, and then it should take as input a price, which is a number. Okay, so we got the method signature done. But now we have to implement the method so that it returns this message. The message starts with the name, a quantity, a total, and then thank you. So I'm going to go ahead and copy this, and then I'm going to paste it in the createOrderSummary method. Now we can start with some base code. The difference though is now the order summary should start with the name, not with the total price. So I'm going to move this to the next line and save it for later. I'm going to initialize the price message variable to name and then Captain Kunal. And then on the next line, I'm going to update the price message. I'm going to append to the existing message, so I'll say price message plus and then the new text. And I want to add quantity and then add the quantity variable. Since quantity is a global variable, we should be able to access it within this method. Okay, so now we have name and quantity. On the next line, I'm going to update the price message again and add some more text. Actually, this text is supposed to be the total price, so I can just use what we had before. Okay, and then on the last line, we update the price message again, take the existing value of that string, and then add thank you to it. This all looks good, but there's still an error here, and it says missing return statement. Since we're supposed to be returning a summary string, then I need to add another line of code that says return and then the return value. In this case, the return value is price message. Then I add a semicolon at the end too. Okay, now the error is gone. It looks like our code is good, so I'm going to run it and test it. Okay, so now if I change the quantity to 3 and I hit the order button, it doesn't work. Let's see what's wrong. Looking at the code more closely, I see what the problem is. There's a warning here that says that the private method createOrderSummary is never used. I forgot to call it. Let's go back to the quiz slide. Okay, so we did the first task successfully, but now I have to call the createOrderSummary method from the submitOrder method. Going back to Android Studio, I need to fix the submitOrder method. I've calculated the price, which is correct, but now I have to pass it into the createOrderSummary method. So I'm going to do that right here. CreateOrderSummary, the price variable. The return value of this method is going to get stored in the price message variable. I don't need this line of code anymore because thank you is already in the text down here. So I can delete that. And then to update the screen, all I have to do is call displayMessage with the price message variable like before. And now let's try to run the app again. If I change the quantity to 3 and I hit the order button, it's still not working. Most of the text is on one line when it should be on multiple lines. So let's go back and fix our code. Looking at this code, I realize that I forgot the new line character. I added it properly for thank you, but not for the others. So I'm going to add it to the other lines now. Okay, now let's try to run it again. And it works! Awesome! Now Captain Kunal can have his 3 cups of coffee. I want to show you some other optimizations you can do to your code. Notice that you could have called the calculatePrice method within the createOrderSummary method, instead of passing it in as an input parameter. So you could have done calculatePrice right here. That would have worked as well. But I wanted to show you that you can take the output of one method and pass it as input to another method. So we'll leave it as we had it before. Within the create order summary method, the other thing I would have done is use the plus equals operator. This is shorthand and it means the same thing as price message equals price message plus all of this. So if I change all of this to be plus equals, it will be the same as what I had before. This just requires less typing so your code is more concise. In the calculate price method, the other thing I would have done is just return the value immediately instead of storing it in a local variable and then returning it. This also leads to more concise code. And then up here in the submit order method, instead of creating the order summary and storing it in a variable and then using it right after, I could have just called create order summary and then called display message on that. This leads to the same thing. The return value of the create order summary method is a string, and that will get passed as an input argument to the display message method. You can leave it like this if you want, if it's easier to read. All of these tips and tricks lead to the same logic anyways. And before I forget, also remember to add a java.comment comment at the top of this method to describe what it's supposed to be doing. Technically, you don't need a java.comment comment for a private method, but it's just good practice to write a description of a method so that other people who are reading your code will also understand what you're trying to do. The description of this method is that it creates a summary of the order. The input parameter is the price of the order, and it returns the text summary. Alright, we just learned a lot about methods. Now it's time for you to take a break. You can do some jumping jacks, you can go take a walk outside, you can even go to a new browser tab. When you're ready, you can come back here and then we're going to look into the display message method, one of my favorite methods. In the next coding task, you're going to modify the app so that instead of saying price here, it's going to say order summary. This is a better name because if you change the quantity and then hit order, then the summary does show up here. It's more than just the price. This is a small UI change, but in the process, you're going to be modifying the display message method, which we gave you in lesson 2 without explaining what it really does. In the coming videos, we'll start to understand more about all the different parts that are going on inside this method. You'll begin by experimenting with changing some of these values and seeing what happens. When you make the change, it will cause an error in the display price method, so you can actually delete this method now. You even get a warning now that says that this method is never used. So go ahead and delete it. The overall goal is to change the price section to be called the order summary section. There's a couple of additional changes we'll be making along the way. In the activity main layout file, go ahead and change the price header to say order summary. Then find the text view for the price value, not the header, but the actual value. Change that view to have an ID of this. The view ID used to be something like price text view, but now that we've changed it into an order summary section, we're going to update the ID as well. Then in the main activity file, in the display message method, go ahead and change the variable name from price text view to order summary text view. And lastly, go ahead and change the reference to r.id.price text view to r.id.order summary text view with the underscores here. When you're done, check these boxes. Then take a moment to step back and make any observations about what's happening in the display message method. Do you have any guesses about what's going on or what the connection is between the XML layout and the Java file? Let's start with the first step, which is to change the price header to say order summary. First I open up the activity main layout file and then I go and find the view that controls the price header. If I put my cursor here, then I see that this view gets correctly highlighted. So now I can go ahead and modify this string here. I'm going to erase this and type in order summary. It correctly updates in the preview window. Notice that I spelled it with a capital O and a capital S instead of in all caps. If we ever decide to change our UI and set all caps to be false, then my text will still be fine. So I prefer typing order summary like this and then using the attribute text all caps equals true. Okay, so the first item's done. The second task is to find the price value text view and change it to have an ID of this. If I move down to the next text view after the order summary header, then this is the price value text view, and it's highlighted here too. As requested, I'm going to change the ID to say order summary text view. Cool, so those are all the XML changes in the layout. Let me run the app to make sure that it still works. Actually, it doesn't work. I get an error saying that I can't find the symbol price text view in the Java file. Looks like we need to go to the next steps before we can get our app to compile. In the main activity displayMessage method, we're supposed to change the variable name from price text view to order summary text view. Within the main activity file, in the displayMessage method, I find the price text view here. I'm going to delete this and then type in order summary text view. It's going to be in camel case and start with a lowercase o, because it's a variable name. Immediately I get a warning that says the variable is never used. So I'm going to copy it and I'm actually going to use it on the next line here because there's an error saying price text view is unresolved. I'm going to delete this and then use the new variable name here. Cool, and that makes the error go away. But I still have another error here, and I think it's related to the last task. The last item here says to change r.id.priceTextView to r.id.orderSummaryTextView. I'm going to double click on this error in red, and I'm going to delete it and type in order summary text view. There, and now the error goes away. And now the app works without any errors. The initial layout is correct. Instead of saying price, it now says order summary. And if I change the quantity and hit order, then the summary shows up here. Let's talk about any observations that you may have made. Remember, there's no right or wrong answers. First, you may have noticed that for the price text view, when we gave it an ID of order summary text view, the similar format appeared again later in the Java code when we were modifying the displayMessage method. You also may have noticed that by changing price to order summary, it seemed to have a bunch of ripple effects on other parts of the code. Now, some of these changes are required in order for the app to run again, but other changes were more nice to haves just for convention so that we didn't have any old lingering references to price. In looking more closely at the displayMessage method, you may have noticed that there's only one input parameter, string message, and there's no return value. That's why we don't have a line in this method that says return something. You also may recognize the word text view, which we saw in the XML in order to add a text view to our layout. It's spelled exactly the same way as here. Also, this line of code here looks like the assignment of a variable, where we have the variable data type, the variable name, and then having an initial value here. This is similar to how we declared integers and strings. And if you were looking really closely, you may have thought that this looks like a method call, findViewById, followed by an opening parentheses, some stuff in the middle, and then a closing parentheses. Similarly with setText here, there's an opening parentheses, something in the middle, and then a closing parentheses. So this may also be a method call. In the upcoming videos, we're going to take a look more closely at what exactly is happening in these lines of code and start to understand what they actually mean. In the last quiz, I asked you to modify a bunch of things in your app. You may not have understood what you're doing, but that's okay. We're going to talk about it now. Specifically, we're going to talk about resources in your app. Resources live under the res directory of your app. Res is short for resources. On the other hand, Java files live in the Java folder, and we have mainActivity.java located inside this folder. An Android app is primarily made up of resources and Java code. The Java code consists of files like mainActivity.java. Altogether, it handles what should happen when the app is running, like responding to button clicks or other events. Then you have resources that live in the res directory of your app. This includes images, text strings, colors, dimensions, like for width and height, XML files, like for menus and layouts, as well as raw media files, like for audio or video. One of the major advantages to separating out the Java code and the resources is that we can provide alternative resources to make the app look better on certain devices. So if we want a different layout on larger screen devices, we can provide that by just swapping it out. Or if we want to translate these strings into another language, then it makes it easier to swap out the strings in just a centralized location instead of having it scattered all over the code files. Now that you know what Android resources are and that you can put them in different folders, let's talk about how you can actually access the resources that you saved in those folders. When your app is compiled, there's a tool in Android called AAPT, and that generates the R class. This is simply an r.java file, and I'll show you an example next. It contains the resource IDs for all the resources in your res directory. So for every resource that you added, now there's an ID to refer to it. The ID is in a format that is based on the resource type. So for all drawable resources, which are graphics, it would follow the format of r.drawable. For all strings that are resources, it would follow the format of r.string, and then the resource name, which is hello in this case. Note that there are two ways that you can access a resource. In Java code, it follows the format of r.resourceType.resourceName. In XML, though, it follows the @ notation. So it'd be @ and then the resource type, which is string, / and then the resource name, which is hello. Here are more examples of different resource types and how to access them. These are just a couple of the common resource types, but there's many others. Just remember that in Java code, you always start with a capital R, a dot, and then resource type, a dot, and then the resource name. And the name is whatever name you assign it. And then in XML, you have @ and then the resource type, / and then the name of the resource. Let's take a moment to find all the resource IDs in our main activity Java file. I'm going to open up the find command in Android Studio. I'm going to use Command F, or you can use Control F if you're on Windows. It pops up a search field here. I'm going to search for capital R dot, and then click on Match Case so that it only grabs the capital R cases. The first thing it finds is this r.layout.activity_main reference. This is interesting because we're referring to the activity main layout file. This is actually how the main activity knows to load up this XML file. Isn't that cool? Let's look at the next reference. Okay, in the displayQuantity method, we have a reference to r.id.quantity_text_view. So this is referring to a view ID, specifically the text view that displays the quantity. Hopefully some of the puzzle pieces are coming together. By referring to this view in the Java code, we can update it while the app is running to show this number of coffees. Let's go to the next occurrence. Okay, in the displayMessage method, we see a reference to r.id.orderSummary text view. Here it seems like we're trying to refer to this text view that displays the order summary so that we can update it with this message. As part of this class, I want you to start to get a glimpse of the whole world of Android. There's so much more that lies beyond this course, beyond Android Studio, beyond the documentation pages that we've read. One of the reasons I love being a part of the Android developer community is because there's so many cool open source apps out there that I can browse. An open source app means that the source code that was used to create that app is made available for other people to see. There are certain restrictions on how you can actually use it, if you can adapt it or modify it, so you have to check the license of the individual app for more details. If you see a really cool feature in an app, you can Google search for it and try to find code for that. If it's an open source app, you might be able to find the exact code, or you might be able to find a library that has that specific functionality that you can look at. Okay, let's try to Google search for some open source Android apps. Then we can see how something like Android resources are used in action. I'm going to Google search for open source Android apps. This Wikipedia link looks good. And there's a whole list of apps here. I want to bring your attention to one app in particular, the Google I/O app. Google I/O is the annual conference organized by guess who, and it's for all the developers who use Google technologies. So Android developers, for example, would attend this conference and learn about the latest changes in Android, how to make their app better, and meet other developers. Let's click on the link to open it. So for this conference, Google creates an Android app, and then the Android app is made open source so other developers can look at the code. This is what the app looks like. It lists all the events for the conference. If you have your own conference coming up and you want to build an app for it, this would be a good example to look at. So anyways, let's go back to the GitHub code. This is where all the code for the Google I/O app is. I'm going to look for how they use resources within a certain activity. I'm going to hit the keyboard shortcut T, and that will immediately begin a search across all their files. It's a pretty nifty shortcut. So I'm going to type activity, and this will show me all files that have activity in the name. Let's look at the welcome activity. And this is the code for the welcome activity. It's a pretty short Java file. To find how they use resources, I'm going to hit Command F, or you can use Control F if you're on Windows. I'm going to search for R dot. I believe Chrome doesn't have case-sensitive search, so I'll just have to search for instances of the capital R myself. So in this first case, we have r.layout activity welcome. It looks like the layout for the welcome activity is stored in the activity welcome XML file. That's pretty cool that we can tell all of that just from this one line. The next resource is here. It says r.id.buttonAccept. Since the resource type is ID and we're talking about a button here, it looks like this is the view ID for the accept button in the app. And the accept button should be in this XML layout. And look, there's something similar down here. It says r.id.buttonDecline. This looks like the view ID for the decline button that's also defined in this XML layout. So stepping back a bit, it looks like this welcome screen has an accept button and a decline button of some sort. But I'm not exactly sure what you're accepting or declining. Let's scroll down some more. The last resource ID is android.r.string.ok. This part looks familiar. r.string.ok. This looks like a string resource. It probably contains the word OK. That's just a wild guess. This is new though. It starts with Android dot. This means that this string resource is provided by the Android system. It's built into Android. It makes sense though, because it's a pretty generic string, so instead of creating our own string that says OK, we can just use the one in the system. Okay, so those were some interesting use cases of resources within the welcome activity of the Google I/O app. Let's navigate back to the root folder of their app to look more at their Android resources. I'm going to click on the Android folder because I think this is where the Android app code is, and then click on Source, Main, and then here's the res directory for all their resources. Inside the res directory, we can see a lot of the folders that we talked about earlier. There's a folder for animation files, colors, graphics. This is the default folder for graphics, and it's called the drawable folder. You can also provide alternative graphics in these other drawable folders. These are for different screen resolutions. We also have layout folders, menu folders, bitmap folders for the launcher icons or the app icons, and we also have values folders. This is the default folder for values. And then you can see all these other folders that start with values, but they have a different ending. This is where you can provide alternative resources like text strings in German or Spanish or French and so on. Or you can provide specific resources for different versions of Android. In the values v21 folder, you would put in resources that are specific to Lollipop devices and above. That's because Lollipop is version 21. Let's look inside the values folder to see what they have. In the colors.xml file, we see a bunch of colors are being defined here. In the dimens file, we see a bunch of dimensions and a bunch of DP values. And in the strings file, we see a bunch of text strings here that appear in the app. Now it's your turn. Go ahead and skim through the articles that we talked about earlier. These are all linked in the instructor notes below. Then try to search for an open source app that you find interesting. Look through one of their activity files and try to identify some uses of resources. Then post about it in the discussion forum. This is a pretty open-ended exercise to help you explore the open source apps that are out there, and we want you to try to identify the things that you've learned in this class within those apps. We look forward to hearing what you find out, and feel free to give other students feedback on the forum as well to help guide them in their learning. When you're done, tell us which app you chose by writing it here. Have fun! Now we know that we can refer to XML resources in the Java code. But what exactly is the relationship between the resources in the Java code? How do they come together as part of a full app experience? Let's start at the point when you click on the Just Java app icon. It opens up the main activity. Now you don't see anything yet because it's still being initialized. Thankfully, a lot of the complexity involved in initializing the activity is handled automatically for you by Android. The important part that we care about is that in the main activity file, the onCreate method gets called automatically. This is when the activity is getting created. It does a bunch of work, and then we have an important line that says set content view and then the resource ID for the layout file. It's r.layout.activityMain. This means that the content view of the activity should be set to the layout as specified in the ActivityMain XML file. This is a method call, and the input parameter is this resource ID. Once you set the layout that you're going to use for the content view, then the Android device can go ahead and start parsing this XML layout file. Parsing is like reading this file and trying to interpret that, like, oh, this is a linear layout, oh, this is a text view, these are the attributes, and so on. So it's trying to understand what this file contains. The Android device starts by reading at the top of the file. It recognizes that there's a linear layout here. Then it inflates a Java object to represent that linear layout. Then it goes to the next line and sees that we need to add a text view as a child to that linear layout, like that. This is starting to look like the view hierarchy from lesson 2. What I didn't tell you earlier is that this is actually a hierarchy of Java objects. We're going to be learning more about Java objects in the coming videos, so it's okay if you don't fully understand it yet. When we get to the next line, we see that we need to inflate a linear layout Java object. That gets added as a child to this root linear layout. Then we see a button element, so we add that as a child to the linear layout. So we continue down the file until we've inflated all the views that we need for our view hierarchy. Once we have this view hierarchy of Java objects, then we can manipulate them and change them while the app is running. An object like the text view here contains state information, like the text color, the text size. The object also has methods, so we can call those methods and change that internal state. So for example, we can change the text while the app is running. Interacting with all of these objects is called object-oriented programming. We will cover this in more detail in the coming videos. So to summarize, in the main activity when we call setContentView to this layout, then we read this layout and then inflate a bunch of Java objects. These Java objects make up the view hierarchy of the app. The main activity holds on to this view hierarchy, and then as you interact with the main activity, it can update these objects. Do you remember the boxes?
What boxes?
These boxes.
Huh.
You do remember them?
Oh yeah, I do remember them. They're
Okay.
variables where you can put the value inside.
Yeah, and you can combine multiple of these variables to create a larger Java object.
Oh, okay, so you can take 2 or more variables and make into something bigger.
Exactly.
Okay. Like a text view.
Yeah, so we can have an integer variable.
This is for the font size.
Exactly.
Okay.
And then you can also have a string variable.
And the string variable for the actual text itself.
Yeah. And those can go inside the text view as the state of the text view.
And then we can interact with those things using different methods that we're going to play with next.
Exactly.
Okay, let's do that.
As we mentioned earlier, showing a text view on the screen like this is actually controlled by a Java object within the app. This is an example of a text view Java object. It's like a box, and inside of it, it holds state. The state is made up of a bunch of fields. A field is a variable, like in lesson 2 when we learned about global variables. We can have a text field to store the today string, which is going to be the text that's ultimately displayed on the screen. We can also have an integer field to store the font size of this text. There's also a bunch of other fields like text color, font family, that make up the state of the text view. I just didn't draw them in this picture. To interact with this Java object and change it while the app is running, we can call methods on the text view. We learned about methods earlier in lesson 3. Some example methods on a text view are setText and getText. You can also have methods like setTextSize or getTextSize and so on. Each of these methods just executes a list of instructions. You can have more complex methods like onDraw, which handles drawing the text view onto the screen. So overall, this text view object holds state information on what this text view contains, and you can call methods to interact with this text view, such as to modify the state or to do more complex actions. To show an image view on the screen, we actually have a Java object for image view inside of the app. This particular image view contains state information like which image should be shown, as well as the scale type, like center crop. Again, there's a bunch of other fields that make up the state of an image view. I just didn't draw them here. There's methods like setImage, setScaleType, and even more complex methods like onDraw to handle drawing this image view onto the screen. Note that as developers, we don't explicitly have to call onDraw to tell it to draw onto the screen. Android handles calling this automatically for us. But it is useful to be able to call these methods to change the image view, for example. So how do we know what all the fields are inside the state of an image view and what all the methods are of this image view? To answer that question, we have to look at the class definition for that object. It's a file called textview.java, similar to how we define mainActivity.java. Inside this class textview file, we have a bunch of code that talks about the state of the text view as well as the methods. Now it doesn't say state and methods exactly, but it just contains information on the state and contains information on the methods. You can think of this as defining the rules of how a text view behaves. This object instance can hold specific information like the text string today or the text size 18. You can also use this class to create even more text view object instances. And these could have a different text string value, like this one could hold text that says hello, and this one could hold text that says goodbye. They could have different font sizes, different text colors, and etc. However, they're all based off of the class template. You may find it hard to distinguish between a class and an object instance, but that's okay. It takes some time to get used to. Here's an analogy to help you. You can think of it as creating a floor plan for a house. You can use this floor plan to create the actual homes. Each of these homes can be slightly different, but they're all based off of this base floor plan. It's important to note that the floor plan is not a house itself. It's just the plan. Similarly, the TextView class is used to create these object instances. So these instances are the ones with the actual text values, text color values, and text sizes. So what does one of these classes look like? We've created a simplified version of the TextView class, which would be saved in the textview.java file. We simplified it so it'd be easier for you to understand what a class would look like. First, it starts with an access modifier. It's marked as public so that other things, like an activity, can use this TextView class. Then we have the word class. This indicates to Java that this is a class definition. Then we have the name of the class. The name of a class in Java starts with a capital letter and is in camel case, so there's no spaces and a capitalized subsequent words. There's some other text here, but we'll look into that later. The important thing is we have an opening brace, and then at the bottom of the definition we have a closing brace. Now inside this TextView class, we have a bunch of variables here. Each of these represents a field in the text view. So we have a field for the text of the text view and a field for the text color of the text view. There are other fields as well, but remember this is the simplified version of the TextView class. We also have a variable to store a reference to the context of the application. You can read more about context in the instructor notes below, but it's basically a way to access information about the app. Like for example, you can access resources in the app using the context. And these are the methods of the text view. The setText method takes as input a text string. Then it updates the global variable mText to use this new value. Similarly, the setTextColor takes as input a new color, and it updates the internal state to have this new color value. There's also methods like getText and getTextColor, which return the internal text string or the internal text color. One more thing, you may have noticed that these global variables here all start with a lowercase m. M stands for member variable, and these are all member variables of this TextView class. Member variable is just another way to say field or the state of the TextView class. Here's a simplified ImageView class. You would find it in the imageview.java file. It starts with public class, and then ImageView is the name of the class, and then we have opening and closing braces. This makes up the state of the image view. Normally it would have more fields than this, but I just want to show you an example. This is an integer variable, and it's called mImageID, M for member variable. This stores the resource ID for the image that should be shown in this image view. Down here we have the constructor, which is used to construct a new image view object, and it takes as input a context, and then it initializes these variables. Then we have a method. It's called setImage, and it takes as input a resource ID for the new image that should be shown in this image view. Inside this method, we update the internal variable for image ID. Again, we created these simplified text view and image view classes to help you understand the concept of classes. Now let's look at the real version of these classes inside the Android framework. To see the code for the Java classes in Android, you can install this Chrome extension. If you're not using the Chrome browser, you can see the instructor notes below for how to access these files. Okay. Once that Chrome extension is installed, then when I search for something like TextView Android and I go look at the reference documentation for this class, then there's going to be this extra link here that says View Source. This is really for advanced developers if you're curious about the code that is used to create this text view. This is a TextView Java file that was defined by someone on the Android team. As you can see, it's really long and complex, but it still has the main parts of a class. It starts with public, class, and then TextView, the name of the class, and then this is the opening brace, and the closing brace is all the way at the bottom here. For example, we see that text color is a field. We also see that text is a field. And here's the constructor for TextView that takes as input a context. If I hit Command F or Control F if you're on Windows, then I can try to search for set text. And here's the set text method. This method is going to set the string value of the text view. And if I search for get text, then I also see this method returns the text that the text view is displaying. You get the idea, and you can browse through this on your own if you want. If I search for the image view documentation page, then I can click on View Source to view all the code for the image view class. The file says public class image view, and then these are the fields that make up the state of the image view, and then there's a bunch of methods at the bottom of the file. The code in this file is pretty complex as well, and it's also thousands of lines of code. The best part about object-oriented programming, though, is that you don't need to know about all these details. As a developer, you can use text view and image view in your app without knowing about all the gory details of what's going on inside of it. We've created a simplified version of the TextView class, which would be saved in the textview.java file. We simplified it so it'd be easier for you to understand what a class would look like. First, it starts with an access modifier. It's marked as public so that other things, like an activity, can use this TextView class. Then we have the word class. This indicates to Java that this is a class definition. Then we have the name of the class. The name of a class in Java starts with a capital letter and it's in camel case, so there's no spaces and a capitalized subsequent words. There's some other text here, but we'll look into that later. The important thing is we have an opening brace, and then at the bottom of the definition we have a closing brace. Now inside this TextView class, we have a bunch of variables here. Each of these represents a field in the text view. So we have a field for the text of the text view and a field for the text color of the text view. There are other fields as well, but remember this is the simplified version of the TextView class. We also have a variable to store a reference to the context of the application. You can read more about context in the instructor notes below, but it's basically a way to access information about the app. Like for example, you can access resources in the app using the context. And these are the methods of the text view. The setText method takes as input a text string. Then it updates the global variable mText to use this new value. Similarly, the setTextColor takes as input a new color, and it updates the internal state to have this new color value. There's also methods like getText and getTextColor, which return the internal text string or the internal text color. One more thing, you may have noticed that these global variables here all start with the lowercase m. M stands for member variable, and these are all member variables of this TextView class. Member variable is just another way to say field or the state of the TextView class. Here's a simplified ImageView class. You would find it in the imageview.java file. It starts with public class, and then ImageView is the name of the class, and then we have opening and closing braces. This makes up the state of the image view. Normally it would have more fields than this, but I just wanted to show you an example. This is an integer variable, and it's called mImageID, M for member variable. This stores the resource ID for the image that should be shown in this image view. Down here we have the constructor, which is used to construct a new image view object, and it takes as input a context, and then it initializes these variables. Then we have a method. It's called setImage, and it takes as input a resource ID for the new image that should be shown in this image view. Inside this method, we update the internal variable for image ID. Again, we created these simplified text view and image view classes to help you understand the concept of classes. Now let's look at the real version of these classes inside the Android framework. To see the code for the Java classes in Android, you can install this Chrome extension. If you're not using the Chrome browser, you can see the instructor notes below for how to access these files. Okay. Once that Chrome extension is installed, then when I search for something like TextView Android and I go look at the reference documentation for this class, then there's going to be this extra link here that says View Source. This is really for advanced developers if you're curious about the code that is used to create this text view. This is a TextView Java file that was defined by someone on the Android team. As you can see, it's really long and complex, but it still has the main parts of a class. It starts with public, class, and then TextView, the name of the class, and then this is the opening brace, and the closing brace is all the way at the bottom here. At the top of the class, we see a bunch of fields here, and this makes up the state of the class. For example, we see that text color is a field. We also see that text is a field. And here's a constructor for TextView that takes as input a context. If I hit Command F or Control F if you're on Windows, then I can try to search for set text. And here's the set text method. This method is going to set the string value of the text view. And if I search for get text, then I also see this method returns the text that the text view is displaying. You get the idea, and you can browse through this on your own if you want. If I search for the image view documentation page, then I can click on View Source to view all the code for the image view class. The file says public class image view, and then these are the fields that make up the state of the image view, and then there's a bunch of methods at the bottom of the file. The code in this file is pretty complex as well, and it's also thousands of lines of code. The best part about object-oriented programming, though, is that you don't need to know about all these details. As a developer, you can use TextView and ImageView in your app without knowing about all the gory details of what's going on inside of it. In the last video, I briefly mentioned that a constructor is defined within the class, and it's used to actually create the object instances. So we call the TextView constructor to create this instance, and we call it again to create another instance, and so on. Let's look at the code for how to actually call a constructor. Do you remember how we created a new integer variable named quantity, and we set it to have an initial value of 2? Creating a new object and storing it inside a variable is going to follow a similar format. It'll look something like this. Instead of the int data type, though, we have an object data type. The object data type is whatever we call the class name. In this case, it's TextView. It can be anything as long as it follows the conventions for variable names. So we just call it price TextView. Then we set it equal to a new object, but we can break down this right-hand side further. The right-hand side follows the format of new, followed by the object data type, which is TextView in this case. This is calling the constructor defined in the TextView class, so we have parentheses with the input arguments to the constructor. So if the constructor requires a context object, then we need to pass a context here. Remember that the context object helps you access application resources and other things about the application environment. So altogether, this is creating a new TextView object by calling the constructor, and then it's storing this new object inside a variable called price TextView. And this variable can only hold a single TextView object as defined by its data type. Here's another example of creating an ImageView object and storing it inside a variable. The data type is ImageView, the variable name is CoffeeImageView, and then we have the assignment operator followed by new ImageView. This is spelled the same exact way as the object data type here. Since we're calling the constructor and we have to pass in any inputs, we have parentheses and then we put the inputs in there. Here's a third example that creates a button object and stores it in this variable. The data type is button, the variable name is submit order button, and then we say new button to call the constructor. You can even define your own object data types. Say for example I created a class definition for cat view. Then I could use this line to create a new cat view. In this case, the constructor requires an input string for the name of the cat, so that's why I put tiger in parentheses and pass that into the cat view constructor. To determine what to pass as input to these constructors, you have to look at either the class javadoc file or the class source file. All these cases use the word new to create a new object. If we go back to the Java keyword list, then indeed we do find that the word new is in that list. Sometimes when you're looking at the documentation, it may advise you to use a factory method to create an object. That is, instead of a constructor. Here's an example. To create a new media player, the documentation advises you to use the method mediaplayer.create, and this returns a media player object that can be stored inside this variable. It follows the format of object data type, so media player with a capital M, dot, and then the factory method name, which is create in this case, and then you pass in the input arguments to initialize that media player. Here's another example of how to create a toast. A toast is a message that pops up temporarily in your app and then disappears. So the code starts with toast with a capital T, because this is the object data type, and then we have a dot, and then make text, which is the factory method name. And then we pass the input arguments to create this toast. To know what the factory method name is and what the input arguments are, you'd have to check the documentation for the toast class. In general, in order to know whether you should create an object using a constructor or with a factory method, you can just Google search for how to create that object. Using a constructor is the most common way to create a new object. It's less common that you would need to use a factory method, but to know for sure which one you should use, you can just Google search for how to create that object. Here's a chance to practice with creating objects. In each of these lines of code, there's an error. Figure out what the error is and then write the correct line of code in these boxes below. Let's do the first one. It says textView equals new textView, and then we pass context in as an input parameter to the constructor. The problem with this line of code is that we're creating a new object, but we're not storing it properly in a variable. We're saying that the variable should have data type textView, but we forget to give it a variable name. So the correct code would look something like this: textView followed by a variable name, and then equals new textView. You can call the variable name something else, but we just chose to use textView with a lowercase t. So in this case, the error was missing variable name. Let's do the next one. It says image view, image equals new image view. The problem here is that this is not a valid object data type. Android defines a class called ImageView with a capital I and a capital V, and it's squished together into one word. A valid class name can't have any spaces in it. The variable name looks okay, and then creating the new image view looks okay as well. So the only error was that it had an incorrect class name. In the third statement, we're trying to create a new toggle button. It says toggle button equals create toggle button. We're calling the toggle button class here, so we need to use the Java keyword new, not create. And this is the correct code. It says toggle button equals new toggle button. The problem here was not using the Java keyword new. New is the keyword that indicates that we're trying to create a new object. In the fourth statement, we're trying to create a new toast. You could have Google searched for how to create a new toast and then compared it with this code here. The problem here is that toast needs to be spelled with a capital T, because this is the class name for toast. This is using a factory method like we talked about earlier. This creates a new toast object and then it gets stored in this variable. So the error here was just the incorrect class name. So now that we know how to create objects, how do we use these objects? Let's go back to the displayMessage method that we were looking at earlier. We were trying to figure out what exactly is going on in here. From what we've learned, so far it looks like there's a textView object, and the variable name is called orderSummaryTextView. Then it says a bunch of code that we don't really recognize. But on the next line, we use that variable, orderSummaryTextView, and we try to set the text on it to be this message. Let's find out more about how to call methods like this on objects. When we call a method on an object, it has to follow this format. First, we write the object variable name. In this case, it's title textView. Then we add a dot. Then it's followed by the method name, which is setText in this case. This method is defined exactly this way in the textView Java class. The method declaration also specifies that there's an input parameter of a string. So we put parentheses and then pass in a string as input. Then we end the statement with a semicolon. When you write this line of code, it modifies the title textView object so that it displays this on the screen. The reason we use the object variable name here is because there could be multiple text views in your app. So make sure you're calling the method on the right object instance. When you're specifying input arguments, make sure you're specifying the right arguments in the right order according to the method declaration. So if there's no inputs, you would just have an empty set of parentheses. The way we pass inputs to a method is the same as we learned earlier in lesson 3. And remember to separate the object variable name and the method name with this dot. Here's another example. On that same title text view object, we're going to call the setTextSize method on it. This method takes an integer as input for the new text size. So in this case, we just pass 18 as the new text size. When the Android device executes this line of code, it's going to change this title text view to have a larger font size of 18. In this example, we're calling a method on the text view object that is called warning text view. The method is called setTextColor, and it takes as input a new color. Notice that the color is specified as color.red. So if we look at the documentation for the color class, then we can scroll down and see that red is defined here. There are a bunch of other colors that you can use here as well. So when you call setTextColor, you could call color.blue or color.black. And lastly, here's an example of calling a method on an image view. This image view object has a variable name of welcomeImageView, and we call the method setImageResource on it. This method takes as input the new image that we should set on this image view. We specify the new image as a resource ID in the format of r.drawable. And this is the file name. This is just another use case of using resource IDs in Java code. To get the full list of methods that you can call on a TextView object, just open up the TextView Android documentation page. I can get to it by just searching for TextView Android and clicking here. So this is a page we already recognize, and we already know about the XML attributes that are listed on this page. If I scroll down further, then I can see a list of all the public methods in the TextView class. If you want to find something, you can just use Command F or Control F if you're on Windows. I'm going to look for the setTextColor method, which we used earlier. Here's the setTextColor method, and it takes an integer color as an input param. All these methods were declared as public methods in the TextView class. That's why we can call these methods now. If they were declared as private methods, we wouldn't see them show up here. When you're calling these methods, make sure you're checking what input parameters it requires and you're passing in the inputs in the correct order and of the correct data type. When you're looking at code, sometimes you might not see the dot notation when calling methods. The difference matters whether you're inside a class or outside of a class. Let's look at an example within the TextView class. We have the setText method defined as well as some other method. Say that you want to call the setText method from this other method. You can do so by calling setText and then passing in the input param. But where's the dot and where's the object variable name? Well, this line of code is actually short for this.setTextHello. This refers to the current object instance, and then setText is being called on this object. This is a format we're more familiar with for calling methods on objects. However, the this dot part is implied, and it's optional. So to make our code more concise, we can just call setTextHello. So notice the difference between calling setText within the class and calling setText outside of that class. When you think about it, this makes more sense because it's very clear which text view you want to set the text on, in case you have multiple text views within this class. Here's another difference between being inside the TextView class versus being outside the TextView class. Within the TextView class, you can access private variables and private methods. If you're outside of the TextView class, you can't use methods that are private and you can't access private variables. Within the main activity class, you can only access public methods and public variables from the TextView class. In this quiz, you're going to practice creating a TextView object and then call methods on it. Since this is just for practice, we're going to do this in a new Android app outside of the Just Java app. That way we don't mess up the Just Java app. Open up the project wizard in Android Studio by going to File, New Project. Then you can accept the defaults for all of these. Make sure that you have blank activity template selected. Then click Finish. Once your project gets created, go ahead and run your app on your device. The default behavior should be to see the words Hello World show up here. But now we're going to do something a little different. In the main activity class, we're going to modify the onCreate method. Instead of calling setContentView on this activity main XML layout, we're going to create our own text view and set that here. On the Android developer site, there's a training section where it talks about building your first app. Specifically, I'm looking at the display the message part of the tutorial. It tells you that in the activity_onCreate method, we can create a text view. And here's the code we recognized from earlier in this lesson. We're creating a new text view and we're storing it in a variable called textView. This constructor requires the context as an input parameter. I'm passing this as an input parameter because this refers to the current activity, and an activity is also a context, so this will correctly create a TextView object for us. Then we can call methods on this TextView object. Remember that this is the TextView variable name, not the TextView class. That's why the T is lowercase here. We can call TextView.setTextSize and TextView.setText as examples. When you scroll down, it says to call setContentView and pass in this text view as an input parameter. If you scroll down further, it actually shows you a code sample of the onCreate method. We don't need this part. We're just focused on this part where we're creating a text view and then we're setting that as the content view of the activity layout. Back in Android Studio, in the main activity class, I'm going to modify the onCreate method. I'm going to insert some blank lines here. First, I'm going to create a new text view object using the constructor. I'm going to give it a variable name of TextView, but feel free to call it something else, as long as it's appropriately descriptive of what this is. The TextView constructor requires a context, so I'm going to pass in this to refer to this activity. Then on the next line of code, I'm going to call a method on the TextView object. As soon as I hit dot, it's going to show me all the possible methods that I could call on this TextView object. If I start to type, then it will filter down these autocomplete options. You can see the options have narrowed. I'm going to choose set text, so I can hit enter to use this autocomplete result. Then I can put in a string as an input argument. Now the last step is to change the set content view line. So instead of using this XML layout file, I'm going to just pass in text view. I'm going to save this and then run this on the device. What I expect to happen now is that the screen will show a new text view that says wow on it instead of hello world. And it does. It's a little underwhelming though, so I want you to make it a little more interesting. I want you to call other methods on this text view object, like try to change the color or the text size. If you're even more adventurous, you can try calling other methods on the text view object. Look at the online documentation for text view in order to figure out what the other possible methods are. When you're done, check these boxes to continue. Earlier, I showed you how to create a new text view and then call a method to change the text on it. What if I want to change the text size? I can just call textView.setTextSize and hit enter, and then just pick a random value like 56. And then I can run it on my device. And this is what it looks like. Wow, that's big. Then I can change the text color as well. I can do textview.setTextColor and then pass in a color. I showed you the possible colors earlier, so let me just pick one, like green. When I run this on the device, it shows up in neon green. If you looked at the TextView documentation, you may have found other methods that you can call. For example, you can call textview.setMaxLines. This limits the number of lines that the text view shows to only 2 lines. If the text is longer than that, then it just gets cut off. To test this, we'll need a really long string here. And actually, in order to know whether this is working properly, I should comment this out first. I'm going to run the app to make sure that this string is actually longer than 2 lines of text. Okay, we verified that it's actually 2.5 lines of text. Once I uncomment this line of code to set the max line limit to 2, then when I run the app, then it should truncate this to 2 lines here. And it does. Cool. So hopefully you got some good practice in with calling methods on an object like TextView. It's actually uncommon to call setContentView and then pass in a single view like this. Normally, the content view of your activity will be a lot more complex, and so that's why we would normally leave it as setContentView and then passing in the resource ID of an XML layout. Let's go back to the Just Java app for a moment. Let's look at the main activity class displayMessage method. Things are starting to make a little more sense in here. We already recognize that we're creating a variable called OrderSummaryTextView, and the data type of this variable was TextView. We didn't understand this part yet, though. On the next line, we call a method on this TextView object. We use the same variable name as declared up here. So we call OrderSummaryTextView.setText. Then we pass a string as an input to the method. The string message originally came as an input parameter to the displayMessage method. Now let's dig into this part of the code which we don't understand yet. It looks like findViewById is a method call though, because it's preceding these parentheses with what looks like an input argument. But what's weird is that this method isn't defined anywhere in this class. If I double click on this name and then hit Command F, or Control F if you're on Windows, then we can try to do a search in this file. I only see 2 occurrences of findViewById, and they're used in similar ways. But I don't see any method that's called findViewById. Speaking of which, earlier in the main activity class, we see a call to setContentView. But if you search for this in the file, it's also not defined in the main activity. So where are these methods defined? Well, main activity is actually a pretty short file. It's only about 90 lines long. But there's actually more to this class than meets the eye. The code says extends AppCompat activity. This means that the main activity is an extension of the functionality in the AppCompat activity class. On your computer, if you see action bar activity here, that's okay. That's just an older version of this. The latest version that you should be using is AppCompat activity. An AppCompat activity gives us backward compatibility support on older Android devices. The AppCompat activity is part of the Android support library. It allows us to use the latest UI features on Android while still working on older Android devices. By extending the AppCompat activity class, we're getting all the functionality, all the state and the methods from here within the main activity for free. We don't have to copy and paste any code from here. We can just simply extend that class. If you're interested, you can find out more information on AppCompat activity by Googling for it. Here's the reference doc for the AppCompat activity class. Since I have the Chrome extension installed, I can view the source as well. And this is the code for where the AppCompat activity class is defined. You can see that there's a lot of functionality here. But the key message is that you don't have to understand how it's implemented. All you need to know is that when you extend AppCompat activity, you get all of this functionality for free. At a high level, you can visualize it like this. This is a class definition for main activity, and say you have some methods defined here. When we extend AppCompat activity, then we can access the state and the methods from AppCompat activity. Now they're not physically added to the main activity class, but you can imagine that they're there because you can still reference the state and the methods as well. And that's how our code can refer to things like setContentView or findViewById because we inherited those methods. We didn't define them in the main activity. The main activity is shown as a screen on the device, but we didn't write the code for that in the main activity. We inherited that as well. We don't have the state and the methods from AppCompat activity directly in the class, but now we know that they're there and we can refer to them. Speaking of inheriting things, there's good and bad parts about that. Sometimes we'll want to inherit behavior, but other times we might want to modify it slightly. If you want to change some of the behavior from this inherited class, you can override certain methods. You can add this @override text on top of a method so that the computer knows that you don't want the version of the method from the AppCompat activity, but instead you want this version that you've defined here. This is a tricky topic and it requires a lot of practice, but we have seen one example of overriding a method from the AppCompat activity class, and that method is the onCreate method. By overriding the onCreate method in the main activity, we're specifying our own implementation for what should happen when that method is called. Don't worry if you don't understand this right away. I'm just giving you a brief overview of a bunch of object-oriented programming concepts. It's absolutely expected that you would still have lingering questions and still need to read up more on these topics in order to fully understand them. Another way to visualize the relationship between the main activity and the AppCompat activity classes is to draw a class hierarchy diagram. This is different from a view hierarchy diagram because a view hierarchy diagram shows a tree of views that are shown on a screen. The class hierarchy diagram shows the relationship between different Java classes. We have AppCompat activity as a superclass. Since main activity extends from AppCompat activity, then this is known as the subclass. So whenever you see this class definition, whatever you extend is known as the superclass. And this would be the subclass. So if you created another activity called detail activity and you extended AppCompat activity, this would be the subclass and this would be the superclass. Here's another example of Java class inheritance. If you think about it, the text view, image view, and button views all have some common aspects to them. All of these views have a width and a height on the screen. We haven't learned this yet, but they also have a visibility state, so they can all be made invisible or visible. There are a couple of other properties as well that are common among them. Instead of writing out code for these properties within the text view class, and then copying it over to image view and then button class, we can do something a little smarter. We can create a view class. We can extract the common properties among all of these views and then put them inside this view class. That way, the code only has to be written once. But then how do we make the connection between the text view class and the view class? If you're thinking inheritance, you're correct. In the text view Java file, we're going to define the text view class. That way, we'll inherit all the state and the methods from the view class. Then we won't have to have as much code in the text view class because part of the functionality is already written in the view class. The same would apply for the image view and button classes. We don't have to write as much code. In these files, we only have to write about what's different about the image view compared to the view class. I think of this as specifying a delta. So the image view class only has to specify what's different about the image view compared to the view class. If we don't want to inherit certain behavior from the view class, we can just specify the updated behavior within the image view class or any of these classes. And to remind you of the terminology, in this case, text view would be the subclass and view would be the superclass. If we go back to the documentation for the text view class, we actually understand this part now. It says text view extends view. Now we know that it means that we're inheriting the state and the methods from the view class. And down here is a class hierarchy diagram. It shows that the text view class is inheriting from the view class. And in turn, the view class inherits from the object class. If you explore around, you can find other classes, like the edit text class, which actually extends from the text view class. So it takes the behavior from the text view class and then adds a little more specific functionality to it. So edit text extends from text view, and text view extends from view, and view extends from object. And this is the class hierarchy diagram. There's a lot going on, and you can look at it for hours, but let me just show you one thing on the text view documentation page. I want to show you the method for set visibility. Here's the Java method for set visibility within the text view class. This changes whether the view is visible or not. If I click on this method, it actually brings me to the view class, and then it describes what this method does. So you can see that a text view object has the set visibility method, but it was actually inherited from the view class. So we got this functionality for free from the view class. Okay, we just covered a ton of new concepts. Normally this would be spread out over a semester of a computer science course. We're going to do a little bit of practice now, and hopefully it'll start to connect the dots for you. But know that it'll take a lot more time and practice until you fully grasp these concepts. Okay, for this exercise, I want you to create another new Android app because we don't want to mess up the Just Java app. Once you create the project, then run the app. Once you create your app, you're going to see a main activity file. That main activity file will extend from AppCompat activity. In your version of Android Studio, if the main activity extends from action bar activity instead, that's okay too. That's just an older version of AppCompat activity. By removing this method override, we're going to fall back to the way that the onCreate method appeared in the AppCompat activity class. The presence of this method says we want different behavior in the main activity for the onCreate method. So removing it brings us back to the original behavior in the AppCompat activity class. When you run the app, what do you notice is different compared to when you first ran the app? Write your answer in this text box. Okay, I just created a new project in Android Studio using the project wizard. When I run the app on my device, it just says Hello World. Now I'm going to remove the onCreate method. I select the whole method from the method declaration to the opening and closing braces, as well as the @override text here. Then I run the app on my device. Interesting. Now I see that the app is blank. The hello world text is gone. If I hit undo, then I can take a look at the onCreate method again. It appears that by overriding this method, we're actually causing the hello world text to appear on the screen. And that makes sense because when we call setContentView, this is actually setting the activity main XML layout onto the content view of the activity. So now we're starting to see why it's useful to override the default behavior in the superclass. When we override the onCreate method, then we can actually use the layout that we want. Okay, let's leave this deleted. That was the second task. Moving on to the third task, I asked you to delete the onCreateOptions menu method. So we can select all of this here and then delete it. And now I'm going to run it on my device. Okay, it looks almost the same. The content area is still blank and there's still an app bar with app title. It's kind of subtle, but you may have noticed that the 3 dots here actually disappeared. The 3 dots were for the overflow menu of the app. And apparently, if I hit undo, then the onCreateOptions menu code was actually controlling those 3 dots showing up here. To show you what I mean, I can add that code back in and then run the app again. Okay, so if we override the onCreateOptions menu within the main activity, then these 3 dots appear again. And then I see a menu item in there that says Settings. So again, in the main activity, it's valuable to override the onCreateOptions menu because then we can provide our own menu items instead of just having no menu. Even though we're altering and overriding some of the behavior from the AppCompat activity class, it's still extremely valuable to inherit from this class. It has a lot of complexity behind the scenes, but we don't have to worry about any of it. We just have to specify a few lines of code to customize our activity. Let's go back to the main activity of our Just Java app. Specifically, we were looking at the displayMessage method and trying to figure out everything that was going on in here. Even though the findViewById method is not declared within this class, we know now that it's actually defined in a superclass in the AppCompat activity. Same for setContentView. This is defined within the AppCompat activity class. But what exactly is happening in this method? And why do we need to pass in a resource ID? And why do we have extra parentheses here? To answer that question, I'm going to summarize everything we've learned so far and lead you to why this code exists here. Do you remember this diagram? When you click on the app icon on the device, it opens up the main activity. Within our code, the onCreate method of the main activity gets called by the system. Within this method, we have a method call to setContentView with the resource layout ID. In an earlier exercise, we passed in a single text view for setContentView, but we want more than one view for our app, so we pass in a layout resource ID. This maps to an XML file. Once we set the content view, the activity goes and finds the XML layout file and then reads through each line. For each view, it inflates or creates a Java object for it. It goes through the XML file and then builds up this whole hierarchy of Java objects. When it's inflating each of these views, it's actually calling the constructor, new text view or new linear layout, and then it's passing in all these attributes into the Java object so that it can be set up properly. Notice that we didn't have to write code for new text view or new linear layout and to set the font size. All of it was handled by the inflation process of the activity. To interact with these views while the app is running and to change them, for example, to change the text or to change the buttons, then we need to find these Java objects. Once we find them, we can store them as variables in the main activity. Remember, we're not creating new text views from scratch, we're just finding the existing ones in this view hierarchy. These are the variables we've used so far in the main activity. We have a variable for quantity, price, and price message. This is a mix of local and global variables. To interact with the views in the view hierarchy, we should create variables that reference these specific views. For example, we can create a variable called quantity text view that would refer to this text view here. If you click on the plus or minus buttons in the UI, then you can change the text view text to show a different number. We can also have a variable called order summary text view that points to this text view. When you click on the order button, then the order summary text view will change its text to show the new order summary. So you can see how having variables that point to some of these views would be useful for changing the UI when the app is running. But how do we make the connection between this variable here to this text view? And how do we make the connection between order summary text view here and this text view? Back in the layout XML file, remember that we assigned view IDs to certain views? For this text view, we gave it a view ID of quantity text view. For this view, we gave it an ID order summary text view. It's optional to assign IDs to views, and you only should assign a view ID if you need to refer to that view later. For example, you can assign view IDs to everything. But that's unnecessary. We only really need to refer to these two views later in our Java code, so let's just assign IDs to these two views. Okay, we've established that views have view IDs that we can refer to them later in the Java code. We also established that we want variables that point to these views so that we can manipulate these views. But we still don't exactly know how to make the connection between this variable and this specific Java object. And same for this variable and this Java object. In the AppCompat activity class, I want to show you a specific method. It's called findViewById, and it takes as input a resource ID. The findViewById method finds the view that corresponds with the ID that is passed as an input. And the activity searches for this view in the view hierarchy from the XML that was processed in the onCreate method. So like I was mentioning earlier, the activity onCreate method sets up a view hierarchy, and then the findViewById method goes and finds a view within that view hierarchy. The return value of this method is an object of type view. This left-hand column shows the return value for all of these methods. This means that within our activity code, we can call findViewById, pass in the resource ID of the view that we want, and then it will return a view object, and then we can store that as a variable within the activity. The main activity Java code would look like this. We can call findViewById and then pass in as an input the resource ID of the view that we want. We gave this text view an ID of order summary text view, so here we reference it as r.id.orderSummaryTextView. This method will go and traverse the whole view hierarchy and then look for the view with this ID. Then it will return this Java object as the return value of this method. We can store the return value into this variable on the left-hand side called orderSummaryTextView, and this is a variable of type view. So this returns a view, and we store it inside a view variable. Later in the main activity, we can also call findViewById and then pass in this resource ID, r.id.quantityTextView, which refers to this text view here. This is a text view in the quantity picker. When this is called, the activity will search through the view hierarchy and then try to find the view with this ID. And then it will return this view, and then we can store that in a variable called quantityTextView. This variable also has a data type of view. This explains how you can have a quantity text view and order summary text view variables within the main activity, and that these variables can connect to these Java objects in the view hierarchy. By the way, I listed the data types here of each of these variables in the left-hand column. So these two variables have a type view, as declared here. I added the code that we were just looking at into our app. It says view order summary text view equals findViewById, and then we pass in the resource ID for the order summary text view. But this causes an error in Android Studio on the next line. It says it cannot resolve the method setText. If I add another line of code here, I can show you the types of methods that are valid on this variable. So we just created the order summary text view variable here, and it's of type view, and so on the next line we should be able to call methods on it. But if you look at the autocomplete suggestions, these methods are actually view methods. There's no text view specific methods. For example, there's no setText method. That's why we get an error down here when we try to call setText. You also can't set text size or set text color or any of those. So where are all those methods? Well, the thing is that a text view is a more specific type of view. So if we want to call text view methods, on this object, we need to make sure that this is a text view object. Okay, now the variable is a text view object. But then I get another error that says incompatible types because a text view is required on the right-hand side, but we're finding just a regular view. That's because the findViewById method returns a view. So how do we reconcile this? Well, since text view is a more specific type of view, or put another way, a text view is a subclass of view, we can actually use something called casting. Casting in Java means that we can take the view returned by this method and actually treat it as a text view. So now this right-hand side is actually a text view object. And then we can store it inside this order summary text view variable. I know that this must be really overwhelming because I just mentioned a ton of new concepts. Let me try to explain again. The findViewById method returns an object of type view. By writing this notation, parentheses, with the desired object data type in the middle of it, we're casting this view into a text view. So the whole expression here evaluates to a text view object. Then we can store that in the variable on the left-hand side, which is order summary text view, and it has a type text view. Now on subsequent lines, we can call text view methods on this object. Do you see now how all the text methods are showing up here? Set all caps, set text size, and more. So I can just erase this now because set text should work, and there's no more errors. So if we want to be able to call text view methods, we need to have a text view object. In order to have a text view object, we need to call findViewById and then cast this view object into a text view. The reason why casting works is because this view here in the view hierarchy is actually a text view. If we try to cast it into something like a radio button, that wouldn't work because the order summary text view is actually a text view. So we have to cast it into the appropriate type. Similarly, in the displayQuantity method, we're calling findViewById and we're passing in this resource ID for the quantity text view. This returns a view and we cast it into a text view, and then we can store that inside this variable called quantity text view. This variable has type text view, and so on subsequent lines we can call text view methods on it, like setText. Here's the updated main activity code using casting. We can cast these views into text views so that we can store them in variables that have type text view. So in this list of main activity variables, now quantity text view and order summary text view are type text view. We can call text view methods on these, and we're not just limited to treating them as views. And now we can call text view specific methods on these variables. For example, we can call setText on the order summary text view, and we can call setText on the quantity text view. As you can see, you have to be careful about what data types are being used where. So far, when we've called methods, we haven't worried about the return value because the setText method actually has no return value. Same with the ImageViewSetImageResource method, this has no return value. But other methods can have return values. For example, in the TextView class, we have a getTextSize method. This returns an integer, so we can store the result of this method in a variable called size of type int. Here's another method that has a return value. In the button class, you can call the getHeight method, and this returns an integer value, so you can store it inside a variable. If you tried to store this result inside a string, for example, you would get an error because this method returns an integer. In order to know what type of data needs to be passed into a method and what data type gets returned back from a method, you should check the documentation. For example, in the TextView class, if you call any of these methods, it returns a value of type int. The return value data type is in the left-hand column here. For other methods, you might get void as a return value, or booleans, which we haven't learned about yet, or floats or longs, and etc. This documentation page also shows what are the expected data types for the inputs to each method. For example, the setTextColor method requires an integer as input, and the return value is void, so there's no return value. So check the documentation to know what data types are expected. Otherwise, you'll get errors in Android Studio saying that the data types don't match. Now it's your turn to practice. Below are 4 different code examples. Some of the code may contain errors relating to data types not matching. If you find an error, describe how you're supposed to fix it by writing it in the boxes provided. Otherwise, you can just write no error if the code is perfectly fine. This is going to be a challenging quiz because we just covered a lot of concepts and this code is still pretty new to you. Take your time and check the documentation for these methods. Make sure that the inputs and the return values are correct and that if we're declaring variables, that we have the correct data types here. Also, look up the documentation for these method calls to make sure that we're using the methods correctly. Let's look at number 1. Before I reveal the answer, I'm going to copy this code and paste it into Android Studio. I want to show you what kind of error would come out. Now, when you were solving this quiz, you didn't need to use Android Studio. You could have solved it by just looking at the code here and then writing in the answer. So, whether or not you use Android Studio is fine with me. To make the code work, I created a new project and then I modified the activity main layout file so that it would have a bunch of views with these IDs that we're going to be referencing. I'm not even sure what this layout would look like, but I just wanted to put the views in here with the corresponding view ID names. That way my code will work here. So for number 1, I pasted the code here and I see that there's an error. Android Studio says it cannot resolve the method setText. If you remember from the last video, I mentioned that setText is a TextView method. That means you can only call this method on TextView objects. In this case, we're calling it on nameTextView, and nameTextView was declared to be a view object. We need to change this to be a TextView object. But then we get an error saying that there's incompatible types. A TextView, an object of type TextView is required, but instead it found an object of type view. That's because findViewById returns a view, and this left-hand side requires a text view. That means we have to add this to cast the view returned by findViewById into a text view. Then we can store this whole thing, which is the name text view, into the left-hand side variable. Then the error goes away and we can set text Laura on this text view. The error is on line 1, so I wrote the correct code right here. The general explanation is that we need to cast this view into a text view and then store that inside a nameTextView variable. That way we can call nameTextView.setText, which is a TextView method, on the next line of code here. Let's move on to number 2. I'm going to copy this code and put it into Android Studio. Here's the code I pasted in. The first line of code seems to be correct, there's no errors. But the second line has a red underline and it says there's an incompatible types error. It says a string is required, but instead it found an int. To understand this better, we should look up the method getMaxLines within the TextView documentation. In the TextView documentation, I'm going to search for the getMaxLines method. And here it is. There's no input parameters and the return value of this method is an integer. So that's why Android Studio was complaining, because this method was returning an integer, but we were trying to store it into a string variable. As a result, I need to change this data type of the variable to be an int. Then the error goes away. So the return value of this method is an integer, so we can store it inside this maxLines variable. There is a warning still remaining, saying that the variable maxLines is never used, but this is just a code snippet. I assume that if this wasn't a regular app, we would actually want to use this variable later. So the error is on line 2, and here's the updated code. The general explanation is that the return value of this method should be an integer. Let's move on to number 3. Here's the code for number 3. I copied and pasted the code for number 3 in Android Studio. There's an error message that says incompatible types. An image view was required, but instead it found a view. This is similar to the error we just saw with the text view. This method returns a view, and on the left-hand side, we're trying to store it inside an image view. So we need to cast this view object into an image view. This is valid because the view with the ID icon actually is an image view, so it's okay to cast it into an image view. Now that the right-hand side evaluates to an image view, we can store that into the variable on the left-hand side. This variable has a data type image view, so now everything matches up, and the error is gone. On the next line, we can call an image view method, setImageResource, onto this icon image view object. There is one remaining error saying that it cannot resolve symbol logo. That's because I just didn't add an image in our app with the name logo. If I added that, then the error would go away. So our code here is correct. Here's the correct code where I cast this view into an image view. Lastly, we have number 4. I pasted the code here in Android Studio, and surprisingly, there's no errors. The code is trying to find a view with the ID title, and that should return a view, and that gets stored in this variable called textView. TextView has a data type of view, so that matches with the right-hand side, so this whole line of code is correct. On the next line, we're taking this object, which is a view, and we're calling a setVisibility method on it. The method takes in one input parameter, which is view.gone. I can check the documentation to verify why that is. In the documentation for the view class, I can search for the method setVisibility. I can see that setVisibility is a method within the view class. It takes as input an integer that represents the visibility state. The possible visibility values are visible, invisible, and gone. Since setVisibility is a method within the view class, this is a valid call here. There's no need to cast this into a text view because the method that we're calling is a method of the view class. Now, if we were trying to use a text view method, then we would need to cast it to a text view. So for this question, you should put no error because setVisibility is a view method and it's okay to leave it as a view object. These were hard questions. It's okay if you didn't get them correct. In the next task, you'll have a chance to practice this more.